Welcome to a journey that will take you to the farthest reaches of the universe, a place beyond our wildest imagination, full of wonders and horrors alike. As we delve into the vast unknown, we'll explore worlds so bizarre that they challenge everything we thought we knew about planets, stars, and the cosmos itself. For centuries, Earth was regarded as the lone cradle of life in the universe. We imagined our planet as a unique speck floating in the vast ocean of space. But as the centuries passed, our understanding of the universe slowly evolved. We no longer see Earth as the only world that harbors life. In fact, with each new discovery, it becomes clearer that the universe is far stranger and more chaotic than we ever expected. The story of our expanding understanding of the cosmos began only a few decades ago, when we first confirmed the existence of planets orbiting stars outside of our solar system. For most of human history, the idea that other stars might have planets orbiting them was nothing but speculation. In the early 1990s, scientists were finally able to detect planets outside our solar system, forever changing the way we see the universe. Prior to this, many believed that our solar system was a rarity, a singular phenomenon in the grand expanse of space. But now, we know that the universe is full of planetary systems, some of which are unlike anything we could have imagined. In the decades since that breakthrough discovery, we have found more than 5,000 exoplanets, planets orbiting stars beyond our own. Today, scientists believe that most stars in the galaxy likely have their own planetary systems. The scope of the discoveries is overwhelming. Each new exoplanet discovered contributes to our understanding of how planets form, how they evolve, and how life might arise elsewhere in the cosmos. The findings so far have been truly astonishing. Some of these exoplanets share features with familiar worlds like Earth, while others have characteristics so strange and extreme that they seem to defy logic. Imagine a planet that rains molten iron, or one so hot that its atmosphere is boiling away into space. Picture a world where the entire surface is covered in violent storms, or one where the landscape is filled with vast oceans of liquid diamonds. These are not the stuff of science fiction. They are real planets, discovered in the past few decades, and they challenge our perceptions of what is possible in the universe. Let's start our journey with one of the most bizarre and extreme planets discovered to date, WASP 76b, a gas giant located 640 light-years away in the constellation of Pisces. WASP 76b is a classic example of a planet that seems to be from another world entirely. Discovered in 2016, this ultra-hot Jupiter orbits its star at an incredibly close distance, just 4 million kilometers away, or roughly 10 times closer than Mercury orbits our Sun. Due to its close proximity, the planet's year lasts only 1.8 Earth days, and the temperatures on its day side soar to a blistering 2,400 degrees Celsius, 4,400 degrees Fahrenheit. What makes WASP 76b even more fascinating is that it likely experiences iron rain. The heat on its day side is so intense that it causes metals, including iron, to evaporate into the atmosphere. As the planet spins, the iron condenses on the cooler night side and falls as molten rain. Winds on this planet blow at staggering speeds, reaching over 18,000 kilometers per h, 11,000 miles per hour, pushing the molten iron across the surface. The conditions on WASP 76b are so extreme that it seems more like a nightmare than a place that could harbor life. But the surprises don't stop there. In 2024, astronomers using the NASA Transiting Exoplanet Survey satellite and the ESA's Characterizing Exoplanet satellite made a groundbreaking discovery: a potential glory on the planet. Glories are rare optical phenomena that occur when light is reflected off spherical droplets in the atmosphere, and for the first time ever, one was observed on an exoplanet. This finding could revolutionize our understanding of planetary atmospheres and atmospheric phenomena. The glory on WASP 76b would be visible in a narrow band between the planet's day and night sides, and if confirmed, this would be the first time such an event was witnessed outside our solar system. WASP 76 B is a prime example of the kinds of planets that continue to surprise and intrigue astronomers, but it's far from the only one. As we explore further, we will encounter even stranger worlds, some of which seem to come straight out of a science fiction novel, and others that challenge our understanding of how planets can form and exist in the first place. One such world is 55 Cancri, a planet located 40 light-years from Earth in the Cancer constellation. At first glance, 55 Cancri might appear to be a relatively ordinary super-Earth, a rocky planet that is more massive than Earth. However, it has a remarkable secret. This planet is essentially made of diamond. 55 Cancri is composed mainly of carbon, and the extreme pressure and heat it experiences from its close orbit around its star have turned that carbon into diamond. The planet's surface is likely covered in vast oceans of molten rock, and while the idea of a diamond planet sounds like something out of a fantasy, it's a very real possibility, supported by astronomical observations. But 55 Cancri is not just remarkable for its composition, it's also an incredibly hostile world. The planet orbits its star in just 18 hours, meaning a day on 55 Cancri is only 18 Earth hours long. Because it's tidally locked, one side of the planet is always facing its star, while the other side remains in perpetual darkness. Temperatures on the day side soar to over 2,000 degrees Celsius, 3,632 degrees Fahrenheit, while the night side remains much colder. With its molten surface and diamond-like composition, 55 Cancri is a world that is far from hospitable. As we continue our journey through these strange and inhospitable exoplanets, we are faced with questions about how planets form, how they evolve, and whether life could ever arise on such hostile worlds. The discovery of 55 Cancri and other planets like it challenges our understanding of the processes that govern planet formation. How did a planet so rich in carbon form so close to its star? How did it end up with a composition so different from anything we find in our own solar system? In addition to these strange planets, we must also consider the role of planetary atmospheres. Many of the planets we've discovered so far have atmospheres that are completely unlike anything we experience here on Earth. Some exoplanets like HD 189, 733b experience winds so strong that they can carry molten glass particles at speeds of up to 7,000 kilometers per h, 4,350 miles per hour. 9b experience surface temperatures that are hotter than some stars, causing their atmospheres to literally boil away into space. One particularly fascinating planet, Kepler 452b, is often referred to as Earth 2.0 inches because of its resemblance to Earth. Kepler 452b is located in the habitable zone of its star, meaning it's at the right distance to support liquid water, a key ingredient for life as we know it. It's also about 1.5 times the size of Earth, which puts it in the category of super-Earths. But while it might seem like an ideal candidate for life, scientists have raised concerns about the possibility that Kepler 452b is headed down the same path as Venus. As its star ages, it may eventually experience a runaway greenhouse effect, causing the planet to lose its oceans and become an inhospitable world. Each of these planets, WASP, 76b, 55 Cancri, HD 189, 733b, and Kepler 452b, represents a unique chapter in the story of planetary exploration. They are just a few of the thousands of exoplanets that have been discovered in the past few decades, and they all highlight the incredible variety of worlds that exist beyond our solar system. While some of these planets are inhospitable, others show promise for harboring life, or at least provide clues about how planets evolve over time. Our understanding of exoplanets is still in its infancy, and as our technology improves, we will continue to make incredible discoveries. The universe is vast, and we have only just begun to explore it. But each new discovery brings us closer to answering some of the biggest questions we have about the cosmos. Questions about the origins of life, the nature of planets, and the potential for life beyond Earth. The universe, as we are beginning to learn, is far stranger and more complex than we ever imagined. So, what will we find next? What other strange and fascinating worlds are out there, waiting to be discovered? Only time will tell, but one thing is for sure, the journey has only just begun. As we venture deeper into the cosmos, the more we uncover, the more we realize just how bizarre and incomprehensible the universe truly is. From planets that rain molten metal to worlds where the very laws of physics seem to bend and break, the universe has a wealth of mysteries waiting to be unraveled. Let's begin our exploration with WASP 12b, a planet located about 1,400 light years from Earth. Known as a hot Jupiter, this massive gas giant orbits so close to its star that it is slowly being consumed. With the temperature soaring above 2,500 degrees Celsius, 4,500 degrees Fahrenheit, it's one of the hottest exoplanets ever discovered. WASP 12b's proximity to its parent star results in extreme tidal forces, causing the planet to stretch and distort, giving it a bloated, egg-like shape. Over time, these forces are tearing the planet apart, and in a few million years it may no longer exist, leaving nothing but dust and gas in space. But the destruction of WASP 12b doesn't end there. The planet is so close to its star that it completes an orbit in just 1.1 days. To put this into perspective, Earth takes 365 days to orbit the Sun, so WASP 12b's year is shorter than an Earth day. Its extreme heat and gravitational pull cause the atmosphere to spill off into space, leading to an ongoing loss of mass. It's a planet on the verge of its own destruction, a slow, agonizing death fueled by the star's relentless pull. However, despite its inhospitable conditions, WASP 12b is of great interest to scientists. By studying the planet's atmosphere, researchers are able to gather data about how planetary atmospheres evolve and how they interact with their parent stars. In the case of WASP 12b, scientists have found that its atmosphere is composed of gases like carbon monoxide, sodium, and titanium oxide. These compounds are not typically found in Earth's atmosphere, and their presence could help scientists learn more about how other planets might support or lack life. While WASP 12b is being torn apart by its star, Kepler 0b offers a glimpse into a future we hope never to experience. Once considered a hot Jupiter like WASP 12b, Kepler 70b is now a barren, lifeless rock, a planet that was once a massive gas giant but has since undergone an extraordinary transformation. Orbiting a star similar to our Sun, Kepler 70b once had an atmosphere and oceans, but these were stripped away over millions of years as the star evolved into a red giant. Today, the planet's surface is an inhospitable wasteland, scorched by the intense heat of the star's dying phases. Kepler 70b's story serves as a haunting reminder of the fate that could await Earth billions of years from now. As our Sun enters its red giant phase, it will expand and swallow the inner planets, including Mercury, Venus, and potentially Earth. In the distant future, Earth could become just like Kepler 70b, a lifeless, burned-out shell of a once vibrant world. But it's not just the future of our own planet that's in question. Kepler 70b shows us that no planet is immune to the inevitable process of stellar evolution. Even the most promising worlds can eventually be consumed by the stars that gave them life. In contrast, we turn our gaze to a planet that has had an entirely different fate. TRAPPIST 1, a star system located just 40 light-years away from Earth, is home to 7 Earth-sized planets. These planets orbit a cool, dim star, making them some of the best candidates for hosting life outside our solar system. TRAPPIST 1 has captured the imagination of astronomers and the public alike, as its planets reside in what's known as the habitable zone, the region around a star where conditions might be right for liquid water to exist. What makes TRAPPIST one particularly intriguing is that several of its planets are in synchronous orbit with one another, meaning they all rotate at the same rate and are likely tidally locked to their star. This could create unique conditions for life, as one side of the planet might be perpetually bathed in sunlight, while the other side remains in eternal darkness. In addition, the possibility that these planets have atmospheres and surface conditions suitable for life makes TRAPPIST one of the most exciting exoplanetary systems discovered to date. But TRAPPIST, one's planets are not without their challenges. The star itself is a red dwarf, a type of star that is much smaller and cooler than our Sun. Red dwarfs are known for their flare activity, and TRAPPIST, one's star, is no exception. These flares could strip away the atmospheres of any planets orbiting too closely, making it difficult for life to thrive. However, even with these challenges, TRAPPIST-1 offers us a tantalizing glimpse into the possibility of life beyond Earth, reminding us that the universe is full of potential waiting to be explored. The discovery of systems like TRAPPIST-1 also challenges our understanding of how life might arise. Scientists have long assumed that life requires planets with specific conditions, like a stable climate, liquid water, and an atmosphere. But with each new discovery, it becomes clear that life could exist in forms we haven't yet imagined, in environments far harsher than we would have thought possible. If life can exist on a planet like TRAPPIST-1e, which is constantly bombarded by radiation from its star, then who's to say what other kinds of life might exist on planets with even more extreme conditions? In our search for life, we cannot ignore the potential that exists on exoplanets orbiting stars far outside our solar system. Planets like HD 40307G, a super-Earth located 42 light-years from Earth, offer tantalizing possibilities. This planet resides in the habitable zone of its star, a G-type star similar to our Sun, and it is considered one of the best candidates for finding alien life. HD 40307G is about 7 times the mass of Earth, making it a super-Earth, a type of planet that is more massive than Earth, but still potentially capable of supporting liquid water and even life. What makes HD 40307G so intriguing is that it orbits its star at just the right distance to maintain a temperature that could support life. Unlike planets like Venus, which are too close to their stars, or Mars, which is too far, HD 40307G is in the sweet spot where liquid water could exist on its surface. If there is water on the planet, it could provide the necessary conditions for life to form. But as with all exoplanet discoveries, there are many unknowns. We cannot yet say with certainty whether HD 40307G has an atmosphere, let alone whether it could support life as we know it. These planets, WASP, 12b, Kepler 70b, TRAPPIST-1, and HD 40307G represent the incredible diversity of worlds that exist beyond our own solar system. Some are inhospitable, others might support life, and some may have already gone through the stages of destruction and rebirth. But no matter what the fate of each planet, they all share one thing in common. They remind us that the universe is full of surprises, and we are just beginning to scratch the surface of what is out there. As we continue our exploration, we will encounter even more strange and mysterious worlds, each one challenging our understanding of the cosmos. The journey to understand these distant planets is just beginning, and with each new discovery, we edge closer to answering the age-old question, are we alone in the universe? Only time will tell. As our understanding of the cosmos expands, we are confronted with more than just the potential for life in distant systems. We are faced with worlds that challenge the very fabric of our understanding of physics and reality. The universe isn't just a collection of stars and planets, it's a cosmic theater where the laws of nature are constantly being pushed to their limits. Take WASP 76b, for instance, a planet that defies everything we know about atmospheric conditions. Located about 640 light-years away, WASP 76b is a massive gas giant, but what sets it apart is its extreme conditions. The planet's proximity to its parent star makes it one of the hottest exoplanets ever discovered, with temperatures soaring to over 2,400 degrees Celsius. But what really makes WASP 76b stand out is the possibility that it rains molten iron. The extreme heat on the planet's day side evaporates metal into the atmosphere, which then condenses and falls back down as liquid iron on the cooler night side of the planet. It's a scenario straight out of a science fiction nightmare, yet here it is, an actual world where molten metal could fall from the sky. WASP 76b's strange weather patterns don't stop at iron rain. Due to its close orbit around its star, the planet is likely tidally locked, meaning one side always faces the star while the other remains in perpetual darkness. This creates a temperature difference so extreme that winds blow at speeds of over 11,000 miles per hour, 18,000 kilometers per h, between the planet's scorching day side and its freezing night side. These winds carry molten metal through the planet's atmosphere, contributing to the bizarre and violent conditions on the surface. If you were to find yourself on the day side of WASP 76b, you'd be facing temperatures that could melt metals and rocks alike, and the winds would be so intense that they would rip through anything in their path. But even stranger than the molten rain and winds is the recent discovery of glories, a rare phenomenon that had never before been observed outside of our solar system. These brilliant circular rings of light are usually seen from Earth during specific atmospheric conditions. On WSP-76b, however, they appear during the transition between the day and night sides of the planet. The light appears to be reflected off clouds made of spherical droplets of a material, likely iron or some other heavy element. The discovery of these glories gives scientists new insight into the planet's atmosphere and the possibility that there could be even more mysterious phenomena to uncover. The fact that such a phenomenon was observed on a planet so far from Earth shows just how much we still have to learn about the vast and strange worlds that inhabit our universe. Yet for all the wonders and oddities of planets like WASP 76b, there are worlds that are so different from Earth that they push the boundaries of our imagination. 55 Cancri, also known as Diamond Planet, is one such world. Located around 40 light-years away in the Cancer constellation, this planet is a super-Earth, meaning it's more massive than Earth but not quite as large as Uranus or Neptune. What makes 55 Cancri truly unique, however, is its composition. It is believed to be made largely of carbon, which, under the intense pressure and heat from its parent star, has crystallized into diamond. 55 Cancri orbits its star, 55 Cancri a yellow-orange star similar to our Sun, in just 18 hours, an incredibly short year. The planet is so close to its star that it experiences extreme heat, with surface temperatures that could reach up to 2,000 degrees Celsius, 3,632 degrees Fahrenheit. The intense heat, combined with the high pressure, has caused the planet's carbon-rich composition to crystallize into diamond. If you were to stand on the surface of 55 Cancri, which, for the record, would be impossible due to the extreme conditions, you would be surrounded by a landscape glittering with diamonds. But this isn't a paradise made of precious stones, it's a world of crushing heat and unrelenting pressure, where even the hardest materials can barely survive. Scientists are fascinated by 55 Cancri because it offers a glimpse into a completely different type of planetary formation. Unlike Earth, which formed from rocky materials, 55 Cancri's formation likely involved a process that created a planet dominated by carbon and diamonds. It also raises the intriguing possibility that there could be other diamond planets out there waiting to be discovered. The discovery of these unusual worlds challenges our assumptions about what planets can look like and how they can form, and it shows just how varied and diverse the universe truly is. But as we venture farther out into the cosmos, we begin to encounter even more mysterious and potentially hostile worlds. One such planet is HD 189733b, a world that is so violent and chaotic that it seems like something out of a post-apocalyptic science fiction novel. Located about 63 light-years away, HD 189733b is a hot Jupiter, meaning it is a massive gas giant orbiting very close to its star. The planet's surface temperature is more than 1,000 degrees Celsius, 1,832 degrees Fahrenheit, and its winds are so intense that they can reach speeds of up to 5,400 miles per hour, faster than the speed of sound. The planet's atmosphere is composed of toxic gases, and the clouds are made of molten glass, which is carried across the planet by the howling winds. The most terrifying part of HD 189733b, however, is the rain. Unlike Earth's gentle showers, the rain on this planet is made of molten glass. As the planet's high winds whip the glass particles across the surface, they create a deadly storm of sharp, burning glass shards. If you were to find yourself on HD 189733b, again a near impossible scenario, you would be subjected to intense heat, powerful winds, and constant showers of molten glass. It's a planet where survival is impossible, and it's a chilling reminder of the hostile environments that exist in the universe. What makes HD 189733b even more fascinating is that it is one of the best studied exoplanets, and it has provided scientists with valuable data about the behavior of hot Jupiters. By studying its atmosphere and weather patterns, astronomers can learn more about the processes that govern these extreme worlds. Despite its inhospitable conditions, HD 189733b is teaching us more about the violent forces that shape planets and how they interact with their parent stars. These planets, where CSP 76b 55 Cancri HD 189733b, represent just a few of the countless exoplanets that exist beyond our solar system. Some of these worlds are inhospitable. Some are filled with strange and deadly phenomena, but all of them are unique in their own way. They challenge our understanding of the universe and push the boundaries of what we thought was possible. As we continue to explore the cosmos, we are sure to uncover even more bizarre and terrifying worlds, each one more surprising than the last. With each new discovery, we are reminded of the vastness of the universe and how much we have yet to learn. While some of these planets may be inhospitable to life as we know it, they provide us with invaluable information about the forces that shape planets and the processes that govern the cosmos. As our technology continues to improve, we will be able to peer even further into the depths of space, uncovering more mysteries and revealing even more astonishing worlds that exist beyond our reach. As we delve deeper into the cosmos, we realize that our understanding of the universe is still in its infancy. The more we explore, the more we are confronted by phenomena that stretch the boundaries of our imagination and challenge everything we think we know about the laws of nature. With every discovery, we find ourselves asking more questions than we can answer, questions that may never be fully resolved. But the quest to understand the universe pushes us forward, even into the most extreme and incomprehensible corners of space. Among the most astonishing discoveries in recent years is the exoplanet KELT 9b, a world so extreme that it redefines what we thought was possible for a planet. Located about 670 light-years away in the constellation Cygnus, KELT 9b is a gas giant that is the hottest known exoplanet in existence. Its surface temperature reaches an unbelievable 4,300 degrees Celsius, 7,800 degrees Fahrenheit, which is hotter than most stars, including our own Sun. The planet orbits a star that is also incredibly hot, with a surface temperature of 10,000 Kelvin, nearly twice as hot as the Sun. KELT 9b's extreme conditions are the result of its close proximity to its parent star, which it orbits every 1.5 days. This means that the planet is subjected to an immense amount of radiation, heating it to temperatures that would incinerate any known material. The atmosphere of KELT 9b is constantly being stripped away by the intense heat, with molecules like hydrogen and helium evaporating into space at an alarming rate. In fact, the planet is losing mass so quickly that scientists predict it could be completely evaporated within a few 100 million years. The conditions on KELT 9b are so hostile that it is impossible for life, as we know it, to survive. But the study of this extreme planet offers a unique opportunity to understand the behavior of hot gas giants and the processes that govern their atmospheres. The data gathered from KELT 9b could help scientists learn more about the early stages of planet formation and the evolution of planetary atmospheres in extreme environments. It also serves as a reminder of just how varied and unpredictable the universe can be. While some planets may harbor life, others are so inhospitable that they seem almost impossible to comprehend. Yet, as we move through the universe, we encounter planets that aren't just inhospitable, they're downright terrifying. One such world is TRAP, PIST, 1D, part of a system located about 40 light years away. TRAP, PIST. 1D is part of a 7-planet system, all of which orbit a small, cool dwarf star, while some of the planets in the TRAP, PIST. One system have been identified as potentially habitable, TRAP, PIST. 1D presents a different challenge. This planet is subjected to tidal heating, which is the result of the gravitational pull between it and its neighboring planets. As a result, TRAP, PIST, 1D's surface is constantly shifting, with massive tectonic activity occurring across the planet's surface. This could create violent earthquakes, volcanoes, and a constantly changing landscape. The atmosphere of TISTSTS 1D is also likely to be dense, with high levels of radiation from the star bombarding the surface. While it may not be the extreme inferno of KELT, 9b, TRAP, PIST, 1D is still an incredibly hostile world, one that would be nearly impossible for any form of life to thrive on. But even in the face of such hostile environments, the search for habitable worlds continues. Scientists are constantly on the lookout for planets that might possess the conditions necessary for life. Planets that lie in the habitable zone, the region around a star where conditions are just right for liquid water to exist. One such planet is Kepler 452b, often referred to as Earth 2.0. This super-Earth, located about 1,400 light-years away, is the closest planet discovered to date that is similar to Earth in terms of size, temperature, and distance from its star. Kepler 452b orbits its star, Kepler 452, once every 385 days, making its year nearly identical to ours. It lies in the habitable zone, where temperatures are just right for liquid water to exist, and its size is about 1.5 times that of Earth. While we don't yet know whether Kepler 452b has an atmosphere or the conditions necessary for life, the fact that it is so similar to Earth makes it a prime candidate for further study. The discovery of Kepler 452b is one of the most exciting in the search for extraterrestrial life, as it suggests that Earth-like planets may be more common in the universe than previously thought. However, even as we search for planets that could potentially support life, we must also confront the reality that not all planets are hospitable, and many of them are so extreme that they defy everything we know about the universe. The discovery of planets like HR 5183b, a gas giant with an incredibly eccentric orbit, shows just how strange and unpredictable planetary systems can be. HR 55183b orbits its star in a long, looping path, taking between 45 and 100 years to complete one full orbit. The planet's orbit is so elongated that at certain points it swings closer to its star than Jupiter is to the Sun, only to swing back out to distances beyond Neptune. This bizarre orbit has earned HR 5183b the nickname the Whiplash Planet, and its discovery challenges our understanding of how planets form and evolve. The most fascinating part of HR 5183b's orbit is that it suggests the planet was once part of a binary star system. At some point, HR 5183b was ejected from its original orbit and sent on a highly elliptical path around its new star. This unusual orbital path has raised questions about the formation of planets in binary star systems and whether they could eventually be expelled from their original orbits, leading to strange and unpredictable orbits, like the one observed in HR 5183b. These bizarre worlds, KELT 9b, TRAP, PIST 1d, Kepler 452b, HR 5183b, are just a few of the countless exoplanets that exist in the universe. Some of these planets challenge our understanding of the basic laws of nature, while others provide us with valuable insights into the processes that govern planet formation and evolution. But no matter how extreme or unusual these worlds may be, they all share one thing in common. They remind us just how little we truly know about the universe. Each new discovery opens up new questions and reveals new mysteries, and the more we learn, the more we realize how vast and strange the cosmos truly is. The deeper we venture into the cosmos, the more we realize that the universe, with all its majesty and enormity, is not merely a vast collection of stars and planets. It is a paradox. It is a place of beauty and terror, harmony and chaos, serenity and violence. The more we learn, the more we understand that the cosmos is a realm of extremes, a universe that defies our understanding and challenges the limits of imagination. Each discovery pushes us further into a space where the familiar rules no longer apply, and we are forced to confront the unknown. Consider the planet WASP 76b, a gas giant located around 640 light-years from Earth, orbiting a star much hotter and more massive than our Sun. Discovered in 2016, WASP 76b presents a world that seems more like a nightmare than a planet, a world where the laws of nature are distorted by the ferocity of the star it orbits. This exoplanet is a perfect example of how extreme and inhospitable the universe can be. Its surface temperature reaches up to 2,400 degrees Celsius, 4,352 degrees Fahrenheit, a heat so intense that it could melt rocks and metals. The planet's day side is scorched by its star, while the night side is freezing cold. The temperature difference between the two sides is so extreme that it generates winds of unimaginable strength, winds that carry molten iron across the planet, creating iron rain. Scientists have even speculated that the atmosphere of WASP 76b may contain clouds made of iron, and that these clouds condense and precipitate as molten iron rain during the night. The temperatures on the day side are so high that the gases on the planet's surface are constantly in a state of flux, moving from one extreme to another, as if the planet itself is constantly trying to balance the forces of destruction and creation. But that is not all that makes WASP 76b extraordinary. In 2021, researchers confirmed the existence of a glory on the planet, an atmospheric phenomenon never before seen outside of our solar system. A glory is a rare optical effect caused by the reflection of sunlight off water droplets or clouds in the atmosphere. The fact that a glory was detected on a planet like WASP 76b, which is so incredibly hostile to life, is both a remarkable and sobering reminder of how strange and unpredictable the universe can be. What is truly astonishing is that WASP 76b is just one example of many exoplanets that challenge our understanding of the universe. The existence of such extreme planets raises important questions about the nature of planetary formation and the potential for life beyond Earth. Can life exist on a world where molten iron rains down from the sky? Could organisms survive on a planet where temperatures swing from blazing heat to freezing cold in a matter of hours? The more we discover, the more we realize that our understanding of life and its potential is far more limited than we once believed. But while planets like WASP 76b push the boundaries of what we thought was possible, they also serve as a reminder that the universe is far more diverse than we could ever imagine. Not all exoplanets are inhospitable or hostile to life. Some are remarkably similar to Earth, existing in the habitable zone, the region around a star where conditions are just right for liquid water to exist. One such planet is Kepler 452b, often referred to as Earth 2.0. Located about 1,400 light-years away, Kepler 452b is a super-Earth that orbits a star similar to our own Sun. It is the first planet discovered that shares many of the characteristics of Earth, including its size, temperature, and orbit. Kepler 452b lies in its star's habitable zone, where temperatures are just right for liquid water to exist on its surface. The planet's size, roughly 1.5 times that of Earth, makes it a prime candidate for studying the potential for life beyond our solar system. 452b has an atmosphere and the right chemical conditions. It could very well harbor life. But the discovery of Kepler 452b is not just about the potential for life, it is also about the possibility of finding a new home for humanity. As we continue to explore the universe, planets like Kepler 452b offer a glimpse into what the future of space exploration could look like. Could we one day colonize a planet like this, ensuring the survival of the human race for millions of years to come? While we are still a long way from such a possibility, the discovery of Kepler 452b has opened the door to new possibilities and has given scientists hope that Earth-like planets are more common than we once thought. However, not all discoveries in the search for habitable planets have been so optimistic. As we continue to study the universe, we are constantly confronted by worlds that are utterly alien and often downright terrifying. TRAPPIST 1D, for example, is a rocky planet that orbits a small dim star about 40 light-years away. While it lies in the habitable zone of its star, scientists have discovered that its surface is subjected to extreme tidal heating, which results in massive tectonic activity and violent volcanic eruptions. The planet is constantly being reshaped by the forces of nature, and its surface is far from the peaceful, life-supporting environment we might expect from a planet in the habitable zone. Even though TRAPPIST 1D is in the right location for life to exist, its extreme conditions make it highly unlikely that it could support life as we know it. In fact, the universe is filled with planets like TRAPPIST 1D worlds that seem to have the right conditions for life, but are ultimately inhospitable due to extreme geological or atmospheric conditions. One such world is HD 189-733b, a gas giant located about 63 light-years away. HD 189. 733b is a planet so extreme that its winds blow at speeds of up to 8,000 kilometers per hour, 5,000 miles per hour, and its surface is constantly bombarded by intense radiation from its star. The planet's atmosphere is thick with silicate clouds, and the temperature on its day side can reach up to 1,000 degrees Celsius, 1,832 degrees Fahrenheit. To make matters worse, the planet's atmosphere is constantly being stripped away by the heat of its star, with the planet losing mass at a rate of up to 3 million tons per second. But perhaps the most disturbing feature of HD 189-733b is the fact that its winds are so powerful that they could literally cut through the atmosphere like knives. The intense heat and high-speed winds make the planet an utterly inhospitable place for life, and it is difficult to imagine any form of life surviving in such an environment. Yet, despite its extreme conditions, HD 189-733b remains one of the most studied exoplanets, as scientists continue to learn from its violent atmosphere and extreme weather patterns. The more we learn about planets like HD 189, the more we realize that the universe is full of worlds that are beyond our comprehension, worlds where the laws of nature are stretched to their breaking point. In our search for exoplanets, we are constantly reminded that the universe is a realm of extremes. Some planets are incredibly hot, others are freezing cold. Some are violently stormy, while others are eerily calm. Some planets may harbor life, while others are completely lifeless. But no matter what we discover, the fact remains that we are just beginning to scratch the surface of what is out there. The universe is vast and mysterious, and with every new discovery, we are reminded of how little we truly know. As we journey further into the cosmos, we begin to move beyond the known, into the territories of the most mind-boggling celestial bodies that science continues to uncover. If you thought exoplanets couldn't get stranger, think again. Our universe is so unpredictable that new discoveries seem to rewrite the very rules we once held dear. Consider for a moment the inhospitable molten surface of WASP 76b, a gas giant situated 640 light-years away from Earth. This planet isn't just a hot spot, it's a boiling cauldron, a world that seems to exist only in the realm of nightmares. WASP 76b's proximity to its host star has caused its surface temperature to soar to unimaginable heights, reaching over 2,400 degrees Celsius, 4,400 degrees Fahrenheit. Imagine a world where iron doesn't just exist as a solid, but rains down in molten form, flowing freely like liquid metal, a bizarre storm of molten iron pouring from the sky.
Scientists studying WASP
76b have speculated that the planet's extreme heat and close orbit to its star may cause its day and night sides to experience radically different temperatures. During the day, the side of the planet facing its star burns with such intensity that the air is filled with evaporating rocks, which then condense as the planet rotates, creating clouds of molten iron. Yet it doesn't stop there. WASP 76b's gravity causes this molten iron to accumulate on its dark side, and it's these very clouds, these iron-filled storms, that might precipitate down as molten droplets during the night. It's a wild, chaotic cycle of day and night that offers a glimpse into a universe far stranger than anything we've seen here on Earth. For a planet this close to its star, the sky isn't the only thing that's scorched. Even the very air, filled with iron particles, carries the weight of this destruction. However, the story of WASP 76b doesn't end with molten iron rains and scorching heat. This planet is part of a growing list of exoplanets that are eerily alien in nature, worlds that defy logic, breaking the norms of planetary formation. While some exoplanets are larger or smaller than anything seen before, 76b remains a symbol of how distant planets, once thought to be impossible, are becoming startlingly real. It's not just the extreme conditions on WASP 76b that fascinate us, but the fact that science is now beginning to collect data on these worlds, worlds that are hundreds, if not thousands, of light years away. Consider this. When scientists first began detecting exoplanets, they used methods like the transit method, where a planet blocks out a portion of its star's light as it moves across the sky. Over the years, they've developed ever more sophisticated ways of observing these worlds, using instruments like the Kepler Space Telescope and the Transiting Exoplanet Survey satellite. But as these telescopes reveal more about distant exoplanets, it becomes clear that we're only beginning to scratch the surface. And yet, there is something haunting about the thought of how little we truly understand about these planets and their environments. The next mystery comes in the form of planets that don't just defy expectation, they create new categories entirely. Take, for example, the planet 55 Cancri, a world made of almost entirely diamond. Yes, you heard that right, a planet that could potentially be more precious than all the diamonds on Earth combined. Located about 40 light-years away in the constellation Cancer, 55 Cancri is an exoplanet that has intrigued scientists ever since its discovery. With a mass 7.8 times that of Earth and a composition primarily of carbon, scientists speculate that the planet's close orbit to its star has caused the carbon to crystallize into diamonds. This extraordinary discovery challenges our preconceived notions about what planets can be made of. For many, the idea of a planet made entirely of diamonds sounds like a science fiction dream, but it's becoming clear that the universe is capable of creating worlds far stranger than we could ever imagine. On 55 Cancri, the heat and pressure near its star are so intense that the carbon on the planet has undergone a transformation, turning it into solid diamond. What's even more surprising, however, is that this planet may not be as alien in nature as we once thought. Despite its extreme conditions, scientists have found that planets like 55 Cancri can provide valuable insights into the formation of planets in our own solar system. Their existence serves as a reminder that planets aren't bound by a single set of rules. Each new discovery adds to the larger picture of how our universe works, even if it doesn't align with anything we've seen before. This brings us to an equally fascinating discovery: the potential for life on planets we never thought would support it. In 2015, astronomers discovered Kepler 452b, a planet that has earned the nickname Earth's cousin. Located 1,400 light-years away from Earth, Kepler 452b lies in the habitable zone of its star, much like Earth does with the Sun. This region, often referred to as the Goldilocks zone, is the sweet spot where conditions are just right for liquid water to exist on a planet's surface. This discovery sparked excitement among the scientific community, as it's one of the most Earth-like exoplanets ever found. However, even as we marvel at the possibility of life on planets like Kepler 452b, it's important to remember that the universe is not as straightforward as we'd like it to be. Kepler 452b's star, although similar in nature to our Sun, is about 1.5 billion years older, meaning that the planet might be subject to much more intense radiation and heat than Earth ever experienced. This raises questions about the long-term habitability of Kepler 452b and how other factors, such as its atmosphere and the nature of its surface, might impact its ability to support life. In the grand scheme of things, Kepler 452b serves as a reminder that even though we are still far from understanding the vast complexity of the universe, there are worlds out there that resemble our own. And though we might never set foot on these distant exoplanets, each new discovery is a piece of the cosmic puzzle that continues to evolve. Every star, every planet, every moon that we uncover brings us closer to understanding the universe's true nature, and perhaps to answering the age-old question, are we alone in the universe? Yet even as we search for the familiar, we encounter the utterly alien, planets that bear little to no resemblance to Earth at all. Consider HD 189, note 733b, a planet so hostile that its rains are made of molten glass, capable of cutting through anything that gets caught in its torrential downpours. This exoplanet, located 63 light-years away from Earth, has temperatures that soar to more than 1,000 degrees Celsius, 1832 degrees Fahrenheit, making it impossible for any life as we know it to exist there. The planet's atmosphere is filled with scorching winds that carry shards of glass, moving at speeds of 4,000 miles per hour. These winds, combined with the planet's intense heat, create a hellish environment that is as alien as it gets. HD 189. 733b is what scientists call a hot Jupiter, a gas giant that orbits its star at an incredibly close distance, resulting in scorching temperatures and extreme weather patterns. And just like that, we encounter another example of how the universe can present us with worlds that are both awe-inspiring and terrifying in their extremes. For scientists, the study of these extreme exoplanets offers us a glimpse into what might be happening on other planets, in distant corners of the universe, worlds that defy our very understanding of what makes a planet habitable. But perhaps the most terrifying part of these discoveries is the realization that for every Kepler 452b or Earth-like exoplanet, there are countless other planets where the conditions for life as we know it do not exist. Some planets may have atmospheres too thick, while others may be bombarded by radiation or scorching heat. Still, these extreme worlds serve as a reminder of the incredible diversity that exists across the universe. And as we push the boundaries of our understanding, one discovery at a time, we can only imagine what other strange and wondrous worlds await our gaze. As we continue to explore the depths of the universe, we encounter not only planets and stars that stretch the limits of our imagination, but also celestial phenomena that exist beyond the comprehension of most. Just when we think we have uncovered the most bizarre worlds in existence, new discoveries reveal even more strange and frightening realities. The universe, it seems, has no boundaries for what is possible or impossible. One such phenomenon, perhaps, one of the most baffling, is the discovery of rogue planets. These are worlds that wander the vastness of space without the tether of a star, isolated and lost in the cosmic abyss. For these planets, their existence is defined not by the warmth of a nearby sun, but by the cold silence of the void. They drift aimlessly, their atmospheres and surfaces continuously bombarded by the elements of space, without the shelter of a gravitational pull to guide them. One rogue planet in particular, known as CFB DSIR 2149-0403, is located roughly 100 light-years from Earth and is unlike any other planet we have observed. It is a free-floating planet, meaning it does not orbit any star and instead roams the universe on its own. With a temperature of around 400 degrees Celsius, 752 degrees Fahrenheit, CFB DSIR 2149-0403 is incredibly hot, and yet it is cut off from the energy and warmth of any nearby star. Its isolation is profound, a cold, desolate world wandering through space, alone. The implications of such rogue planets are vast. Not only do they challenge our understanding of planetary formation, but they also raise questions about the true diversity of planetary environments in the cosmos. One theory suggests that they are ejected from their original solar systems due to gravitational interactions with other planets or stars, while another theory posits that they may have formed independently in the dark regions of interstellar space, where no star exists to fuel their development. In many ways, these rogue planets represent the ultimate in cosmic loneliness. Yet, there is a strange beauty in their isolation, a reminder of how planets, like people, can be cast adrift in the universe, searching for meaning or warmth in a seemingly indifferent cosmos. However, rogue planets are not the only examples of celestial objects that challenge our understanding of the universe. Consider the discovery of the planet KELT 9b, a gas giant that is hotter than most stars. Found 650 light-years away in the constellation Cygnus, KELT 9b is the hottest known exoplanet, with temperatures that soar to a staggering 4,300 degrees Celsius, 7,800 degrees Fahrenheit. This temperature is not only higher than the surface of Venus, but also hotter than the surfaces of many stars. How can a planet be so incredibly hot, and what does it mean for the future of planetary science? KELT 9b's extreme heat is a result of its proximity to its parent star. The planet is locked in a tight orbit around a star that is far hotter and larger than our Sun. This star, an A-type main sequence star, is about twice the size of our Sun and has a surface temperature of over 10,000 degrees Celsius, 1832 degrees Fahrenheit. The intense radiation from this star bombards KELT 9b, heating it to temperatures that are beyond anything we experience in our solar system. The planet's surface is so hot that even metals such as titanium, iron, and aluminum are vaporized, creating a thick, metallic atmosphere that is unlike any other planet we know. But the heat isn't the only striking feature of KELT 9b. Its days and nights are incredibly fast, with one complete orbit around its star taking just 1.5 days. This ultra-short orbital period means that the planet experiences extreme temperature fluctuations, with one side continuously facing its star and the other trapped in perpetual darkness. This creates a dramatic contrast between the scorching day side and the freezing night side, with winds that whip through the planet's atmosphere at incredible speeds, making it one of the most hostile environments we've yet discovered. Despite its extreme conditions, KELT 9b is an invaluable object of study for astronomers. By studying its atmosphere, scientists are gaining insight into the atmospheric chemistry of distant worlds. The heat and unusual composition of the planet's atmosphere provide valuable data that could help us better understand how planets form, evolve, and interact with their stars. It's a reminder that while the universe may be indifferent to our survival, it continues to offer us lessons in the most unexpected ways. But as we venture deeper into the exploration of planets and their bizarre characteristics, we must not overlook the possibility that there are still countless mysteries waiting to be uncovered. Each discovery, from rogue planets to ultra-hot gas giants, reveals only a tiny fraction of the complexities of the universe. For every exoplanet we find that challenges our understanding, there are likely hundreds more that remain hidden, waiting for the moment when the right technology or discovery technique will reveal them to us. Consider, for instance, the detection of a planet known as 51 Pegasi b, the first exoplanet ever discovered around a Sun-like star. This groundbreaking discovery, made in 1995, opened the floodgates for the study of exoplanets and sparked a wave of research into the nature of distant worlds. Since then, scientists have discovered thousands of exoplanets, each more intriguing and complex than the last. Yet, despite the enormous progress we've made, the true number of planets that exist in the universe remains an unsolvable mystery. With over 100 billion galaxies in the observable universe, each containing billions of stars, the potential for undiscovered planets is vast. So, as we look toward the future, what does the discovery of these strange and incredible worlds mean for us? Are we on the verge of finding a new Earth, a second home among the stars? Or are we simply uncovering more of the harsh realities that exist beyond our solar system? One thing is for certain: the universe is full of surprises, and the more we learn, the less we realize we know. Whether it's the discovery of molten iron rains on WASP 76b, the eerie isolation of rogue planets, or the extreme heat of Chi-ELT 9b, each new finding challenges our assumptions and pushes the boundaries of what we thought was possible. But beyond the science, there's something more profound happening. Each new discovery takes us one step closer to understanding not only the cosmos, but also our place within it. With each exoplanet we uncover, we not only learn about the universe around us, we learn about the possibilities of life, of survival, and of the unknown frontiers that await us in the farthest reaches of space. Our exploration takes us deeper into the heart of the cosmos, where we find not only planets and stars, but also the enigmatic forces that shape them. The universe, with its vast array of celestial bodies and phenomena, is not only a place of wonder, but also a realm of danger and unpredictability. From planets that seem to burn with an intensity beyond comprehension, to celestial events that could tear the fabric of space itself, every discovery reveals just how fragile our understanding of the cosmos truly is. Among the most mysterious of these celestial forces is the phenomenon of black holes. These cosmic giants, with their intense gravitational pull, defy the very laws of physics as we understand them. Black holes are born when massive stars collapse under their own gravity, forming a singularity, a point of infinite density. Surrounding this singularity is the event horizon, a boundary beyond which nothing, not even light, can escape. The existence of black holes was first predicted by Albert Einstein's theory of general relativity, but it wasn't until the mid-20th century that scientists began to gather evidence that these elusive objects actually exist. The first hint of their existence came in the form of X-ray emissions from certain regions of space. These emissions were thought to be caused by matter being drawn into an unseen object. Over time, astronomers realized that these emissions were likely the result of matter being pulled into a black hole, where it was compressed and heated to extreme temperatures. This process, known as accretion, results in the release of enormous amounts of energy, making black holes some of the most powerful sources of radiation in the universe. One of the most famous black holes is located at the center of our own galaxy, the Milky Way. This supermassive black hole, known as Sagittarius A, is estimated to be about 4 million times the mass of our Sun. Despite its massive size, Sagittarius A remains invisible to the naked eye, hidden behind the dense stars and gas that populate the center of our galaxy. However, astronomers have been able to detect its presence by observing the motion of nearby stars. These stars, which orbit at incredible speeds, are being pulled toward the black hole by its immense gravity. Their rapid orbits provide a direct clue to the mass and location of Sagittarius A, allowing scientists to study its properties in detail. What makes black holes so fascinating is not just their size or their ability to bend light, but their potential to unlock some of the deepest mysteries of the universe. Scientists believe that the study of black holes could provide insights into the nature of space and time itself. For instance, the singularity at the center of a black hole represents a point where our current understanding of physics breaks down. The gravitational forces near the event horizon are so extreme that they cause space and time to stretch and warp in ways that are difficult to comprehend. But perhaps the most intriguing question about black holes is what happens inside them. According to current theories, once something crosses the event horizon, it is lost forever, unable to escape the black hole's grasp. However, the exact nature of what happens beyond the event horizon remains a mystery. Some scientists speculate that the interior of a black hole may contain a wormhole, an opening to another part of the universe, or even another universe altogether. Others suggest that the extreme conditions inside a black hole could lead to the creation of entirely new forms of matter and energy. But until we can observe the inside of a black hole, these ideas will remain theoretical. As we ponder the mysteries of black holes, we must also consider the larger cosmic structures that shape our universe. One such structure is the cosmic web, a vast network of galaxies, gas, and dark matter that spans the entire universe. The cosmic web is a framework of interconnected filaments, each one containing clusters of galaxies bound together by the force of gravity. These filaments stretch across the universe, forming a structure that looks like a spider's web with vast voids in between. The cosmic web is thought to be the largest structure in the universe, stretching across billions of light years. The study of the cosmic web is still in its infancy, but scientists believe that it holds the key to understanding the large-scale structure of the universe. By observing the distribution of galaxies and the cosmic gas that fills the filaments, astronomers can gain insights into the formation and evolution of the universe itself. The cosmic web provides a detailed map of how matter has been distributed throughout space over the past 13.8 billion years. Interestingly, the cosmic web is not static. It is constantly evolving as galaxies move and interact with one another. Some galaxies are pulled toward each other by the force of gravity, while others are repelled by the expansion of the universe. These interactions can lead to the formation of new galaxies, as well as the destruction of older ones. In fact, the cosmic web is a dynamic system, constantly changing and evolving as the universe itself continues to expand. In recent years, astronomers have made significant progress in mapping the cosmic web. Using advanced telescopes and other observational techniques, they have been able to trace the paths of galaxies across vast stretches of space. One of the most significant discoveries in this area was the detection of the Great Attractor, a massive concentration of galaxies that is pulling nearby galaxies toward it. This discovery has provided crucial insights into the nature of the cosmic web and how the universe is structured on the largest scales. But the cosmic web is not the only large-scale structure that shapes the universe. Another important phenomenon is the formation of galaxy clusters. These clusters are massive collections of galaxies bound together by gravity. They can contain hundreds or even thousands of galaxies, and they are some of the largest structures in the universe. Galaxy clusters are important because they provide a window into the formation and evolution of galaxies. By studying the galaxies within these clusters, scientists can learn more about how galaxies form, interact, and evolve over time. Interestingly, galaxy clusters are not evenly distributed throughout the universe. Instead, they tend to form in regions where large amounts of matter, including dark matter, are concentrated. These areas are known as dark matter halos, and they play a crucial role in the formation of galaxies and galaxy clusters. Dark matter, which makes up about 27% of the universe's total mass, is invisible and does not interact with light, making it difficult to detect. However, its presence is inferred by its gravitational effects on visible matter. By studying dark matter halos, astronomers can gain insights into the distribution of dark matter in the universe and how it influences the formation of galaxies. One of the most fascinating aspects of galaxy clusters is their role in the expansion of the universe. As the universe expands, the space between galaxies increases, causing galaxies to move farther apart. However, within galaxy clusters, the force of gravity is strong enough to counteract this expansion, causing the galaxies within the cluster to remain bound together. This creates a paradox in which galaxies within a cluster are moving toward each other, while galaxies outside the cluster are moving away from one another. This phenomenon, known as peculiar motion, is a key area of study for astronomers trying to understand the dynamics of galaxy clusters. But even as we unravel the mysteries of galaxy clusters and the cosmic web, we are confronted by the realization that there is still so much more to learn about the universe. The cosmos is full of unexpected discoveries, from rogue planets to black holes, from galaxies colliding to the invisible forces that hold the universe together. Every new discovery leaves us with more questions than answers, pushing the boundaries of our knowledge and expanding our understanding of the universe. As we continue our journey through the cosmos, the universe continually reveals itself as an enigmatic, ever-expanding mystery. What we thought we knew about the structure of space is just a glimpse into a far deeper and more complex system that transcends our understanding. The further we reach into space, the more we realize how incredibly vast, varied, and strange the cosmos truly is. Our exploration takes us to the very edge of known space and into the heart of phenomena so bizarre they challenge the very foundations of physics itself. One of the most intriguing and yet baffling aspects of the universe is the mysterious substance known as dark matter. Though invisible and undetectable by ordinary means, dark matter is believed to make up about 27% of the universe's total mass. Its presence is inferred through its gravitational effects on visible matter. Without dark matter, galaxies would not have enough mass to hold them together, causing them to fly apart. Yet, despite its crucial role in shaping the cosmos, scientists have yet to directly detect dark matter particles. All we know about dark matter comes from its effects on galaxies and galaxy clusters, where its gravity causes stars and gas to move in ways that cannot be explained by ordinary matter alone. For decades, scientists have proposed various theories to explain what dark matter could be, but the answer remains elusive. Some believe it could be composed of exotic particles, while others suggest that it might be some form of ordinary matter that simply doesn't interact with light. Regardless of its composition, one thing is certain: dark matter is a fundamental part of the universe, and its mystery continues to drive astronomical research. The story of dark matter leads us to another equally perplexing concept: dark energy. While dark matter is thought to be responsible for holding galaxies and galaxy clusters together, dark energy is believed to be the force driving the accelerated expansion of the universe. Unlike gravity, which pulls objects towards one another, dark energy seems to have a repulsive effect, pushing galaxies apart at an ever-increasing rate. This discovery, first made in the late 1990s, completely reshaped our understanding of the universe. For most of the 20th century, scientists believed that the expansion of the universe was slowing down due to gravity. However, observations of distant supernovae revealed that the universe is actually expanding at an accelerating rate, forcing researchers to reconsider their models of cosmology. The exact nature of dark energy remains one of the biggest questions in modern science. It is thought to make up about 68% of the total energy content of the universe, yet we still know very little about it. Some scientists have proposed that dark energy could be linked to the cosmological constant introduced by Albert Einstein in his theory of general relativity. Others suggest that it might be a dynamic field that changes over time, or that it could be the result of modifications to the laws of gravity. The discovery of dark energy has profound implications for the future of the universe. If dark energy continues to dominate the expansion of the universe, it could lead to a scenario where galaxies move further and further apart, eventually isolating each galaxy in an ever-growing void. This scenario, known as the Big Freeze, could result in a universe that grows colder and more empty over trillions of years. As we venture further into space, we are faced with the realization that the universe is not only strange and mysterious, but also vast beyond comprehension. The distances between stars, galaxies, and other cosmic objects are so staggering that they defy our everyday experience. For example, the nearest star to our own Sun, Proxima Centauri, is located about 4.24 light-years away. This is roughly 40 trillion kilometers, or 25 trillion miles. To put that into perspective, if you could travel at the speed of light, about 300,000 kilometers per second, it would still take you over 4 years to reach Proxima Centauri. The vastness of space means that when we look at distant objects in the universe, we are also looking back in time. The light we see from stars, galaxies, and other objects has traveled for millions or even billions of years to reach us. This means that when we observe distant galaxies, we are seeing them as they were in the distant past, not as they are today. In fact, the most distant galaxy ever observed, GN Z11, is located about 13.4 billion light-years away, meaning that the light we see from it today was emitted just 400 million years after the Big Bang. This discovery provides a glimpse into the early universe and helps scientists understand how galaxies formed and evolved over time. Despite the enormous distances in space, we are constantly discovering new objects and phenomena that deepen our understanding of the cosmos. For example, astronomers have recently discovered a class of stars known as fast-evolving massive stars, FEMS, which burn through their fuel at an incredibly rapid rate. These stars are thought to be among the most massive and energetic objects in the universe. Their rapid evolution and explosive deaths contribute to the formation of black holes and the dispersal of heavy elements throughout the cosmos. By studying FEMS, scientists hope to learn more about the life cycle of stars and how elements like carbon, oxygen, and iron are created in stellar explosions. In addition to these massive stars, the universe is also home to a variety of other strange and exotic objects, such as neutron stars, pulsars, and magnetars. Neutron stars are the remnants of massive stars that have exploded in supernovae, collapsing into an incredibly dense object composed almost entirely of neutrons. These stars are so dense that a single cubic centimeter of their material would weigh about 400 million tons on Earth. Neutron stars are also known for their intense magnetic fields and rapid rotation, which can cause them to emit powerful beams of radiation. When these beams sweep across the sky, they are detected as pulsating signals, earning neutron stars the name pulsars. Magnetars, a type of neutron star, are even more extreme. They possess magnetic fields trillions of times stronger than Earth's, and these fields can cause intense bursts of X-rays and gamma rays. The energy released by magnetars can be so powerful that it can cause the surrounding space to be ionized, creating a glowing halo around the star. Despite their extreme nature, magnetars are relatively short-lived, as their intense magnetic fields cause them to lose energy rapidly. These fascinating objects represent just a tiny fraction of the wonders that await us in the universe. Every day, astronomers make new discoveries, each one adding to our understanding of the cosmos and challenging our assumptions about the nature of space, time, and matter. The universe is a vast, unpredictable, and sometimes terrifying place, but it is also a source of endless fascination and wonder. As we continue to explore the stars, we are constantly reminded of the limits of our knowledge and the boundless potential for discovery that lies ahead. As we move deeper into our exploration of the universe, we begin to encounter more extraordinary phenomena that push the boundaries of what we once thought was possible. Space is filled with celestial oddities that not only defy our understanding of physics, but also make us question the very nature of reality itself. One such mystery lies in the fascinating and somewhat terrifying realm of black holes. A black hole, in its simplest form, is an object with such a strong gravitational pull that nothing, not even light, can escape it. They are formed when massive stars collapse under their own gravity at the end of their life cycle. But black holes are more than just gravitational wells. They are enigmas of space and time that challenge the laws of physics. At the core of every black hole lies a singularity, a point of infinite density where the known laws of physics break down. This makes black holes one of the most studied yet least understood phenomena in the universe. Black holes come in several different sizes, but they all share one key feature: the event horizon. This is the boundary around a black hole, beyond which nothing can escape. Once something crosses this line, it is doomed to be pulled into the singularity. Interestingly, The closer an object gets to the event horizon, the slower time appears to move relative to an outside observer. This bizarre effect, known as time dilation, occurs because of the immense gravitational pull near the black hole. For an object falling into a black hole, time seems to come to a standstill, while to an outside observer, it seems to take forever for the object to reach the event horizon. Despite their ominous reputation, black holes are not all-consuming monsters that devour everything in their path. In fact, many black holes are relatively quiet, quietly lurking at the centers of galaxies, including our own Milky Way. These supermassive black holes can be billions of times more massive than the Sun, and they play a crucial role in the formation and evolution of galaxies. The gravitational pull of these massive black holes influences the orbits of stars and can even affect the shape of entire galaxies. But black holes aren't just lurking in the background. They can also be incredibly active, emitting powerful jets of energy as they feed on surrounding matter. When gas and dust fall into a black hole, they form a hot, dense accretion disk that spirals towards the event horizon. As the material heats up, it emits radiation, including X-rays and gamma rays. Some of this radiation escapes in the form of powerful jets that shoot out from the poles of the black hole at nearly the speed of light. These jets can stretch for millions of light years, making them some of the most energetic phenomena in the universe. Perhaps one of the most fascinating discoveries in recent years is the detection of gravitational waves, ripples in space-time caused by the acceleration of massive objects, such as when black holes merge. In 2015, scientists at the Laser Interferometer Gravitational Wave Observatory, LIGO, made the groundbreaking discovery of gravitational waves produced by the collision of two black holes. This detection opened a new window into the universe, allowing scientists to observe the most violent and energetic events in space. Since then, numerous gravitational wave events have been detected, providing insights into the behavior of black holes and other extreme objects in space. Gravitational waves are just one example of how advanced technology is expanding our understanding of the cosmos. Over the past few decades, our ability to observe space has grown exponentially, with telescopes and observatories capturing images and data from objects billions of light years away. The Hubble Space Telescope, for example, has provided us with breathtaking images of distant galaxies, nebulae, and stars, revealing the intricate beauty of the universe in ways we never thought possible. And with the launch of the James Webb Space Telescope, we are now able to look even deeper into space, capturing infrared images that reveal the hidden secrets of the early universe. Yet even with all these advancements, there is still so much we do not know. The universe is filled with mysteries that continue to elude our understanding. We have only scratched the surface of what lies beyond the reach of our telescopes and instruments, and as we continue to explore, we will undoubtedly encounter more strange and wonderful phenomena that will challenge our perceptions of reality and deepen our understanding of the cosmos. One of the most intriguing aspects of space exploration is the potential for life beyond Earth. The discovery of exoplanets, planets orbiting stars outside our solar system, has opened up new possibilities for finding habitable worlds. Scientists have already identified thousands of exoplanets, and many of them reside in what is known as the habitable zone of their star, where conditions might be just right for liquid water to exist. Water, as we know, is essential for life as we understand it, and the presence of liquid water on an exoplanet could be an indicator that life might be possible there. But even more fascinating than finding Earth-like planets is the possibility that life elsewhere in the universe could exist in forms entirely different from what we know. Could life exist in the oceans of a distant moon, thriving in the dark depths beneath the ice? Or perhaps in the acidic clouds of Venus, where extreme temperatures and pressure conditions would seem inhospitable to life as we know it? The search for extraterrestrial life is one of the driving forces behind space exploration, and while we have yet to find definitive evidence of alien life, the discovery of strange, unexpected environments on other planets and moons gives us hope that life might be more common than we think. As we continue to scan the skies for signs of life, we also turn our attention to the future of humanity in space. With advancements in space travel, The possibility of colonizing other planets is becoming more tangible. Plans for human missions to Mars are already in the works, and private companies like SpaceX are working on developing spacecraft that can carry humans to distant planets. Colonizing another planet would present immense challenges, from the harsh conditions of space to the need for sustainable life support systems. But the idea of establishing a human presence beyond Earth is no longer the stuff of science fiction. In the coming decades, humanity may take its first steps toward becoming a multiplanetary species, expanding beyond Earth and venturing into the vast unknown. The colonization of Mars, or even the moons of Jupiter and Saturn, would mark a monumental achievement in human history. And while it is still early in the process, the pursuit of space exploration has already led to numerous technological advancements that have had a profound impact on life here on Earth, from satellite communications to advancements in medical technology. But even as we reach for the stars, we must remember the fragility of our own planet. The Earth is a precious and unique world, and our actions here will determine the future of our species. As we continue to explore the universe, we must also work to preserve the beauty and life that exist on our home planet. The universe is vast, mysterious, and filled with wonders beyond our comprehension, but the Earth remains our home. A home that we must care for and protect as we continue our journey through the cosmos. As we venture deeper into the unknown reaches of the cosmos, we are continually reminded of the vast scale of the universe and the seemingly infinite possibilities it holds. The more we discover, the more we realize how small we are in comparison to the celestial giants that inhabit the universe. Yet there is something awe-inspiring about understanding our place in this great cosmic expanse. The mysteries of the universe are waiting to be uncovered, and our journey into the stars has only just begun. One of the most mind-boggling aspects of space is the concept of time. In the realm of cosmology, time is not just a simple measure of past, present, and future. It is an intricate fabric woven into the very structure of space itself. The immense distances between stars and galaxies create a time dilation effect, meaning that time can pass differently depending on where you are in the universe. For instance, if you were traveling at the speed of light, time would seem to stand still, while to someone observing from a stationary position, time would pass as it normally does. This relativistic effect is one of the key principles of Einstein's theory of relativity, and has profound implications for our understanding of the universe. But time isn't just distorted by the motion of objects in space, it's also influenced by the gravity of massive celestial bodies. Black holes, for example, are notorious for their ability to bend both space and time. The intense gravitational field around a black hole causes time to slow down dramatically the closer you get to the event horizon, the point beyond which nothing can escape. For an observer outside the black hole, it would appear as though time is slowing down for anything approaching the event horizon, and they would never actually see anything fall into the black hole. Instead, the object would seem to hover at the event horizon, frozen in time. This concept of time, as it relates to gravity and motion, is not just an abstract idea, but has practical implications for space exploration. When we send spacecraft to other planets or stars, we must take into account the time it takes for signals to travel between Earth and the spacecraft. For example, when NASA's Curiosity rover sent its first images from Mars, there was a significant delay in the transmission of those images because of the distance between Earth and Mars. It takes light around 13 minutes to travel from Earth to Mars, so any communication between Earth and a spacecraft on Mars is subject to this time lag. The time it takes for light to travel across space is also an important consideration when we observe distant objects in the universe. When we look at stars and galaxies billions of light years away, we are actually looking back in time. The light we see from these distant objects left them millions or even billions of years ago. This means that when we observe the farthest reaches of the universe, we are seeing them as they were long before humans ever existed. In a sense, we are peering into the past, witnessing the events that shaped the universe long before our planet even came into being. One of the most remarkable examples of this is the study of the cosmic microwave background radiation, the faint glow left over from the Big Bang. This radiation, which was first detected in 1965, provides us with a snapshot of the universe as it was just 380,000 years after the Big Bang. It's like looking at the universe's baby pictures, giving us a glimpse into its early history. By studying this radiation, scientists have been able to learn about the conditions that existed shortly after the birth of the universe, shedding light on how galaxies, stars, and planets formed over billions of years. The discovery of the cosmic microwave background radiation also confirmed many of the predictions made by the Big Bang theory, the leading explanation for the origin of the universe. According to this theory, the universe began as a singularity, a point of infinite density and temperature, around 13.8 billion years ago. This singularity then expanded rapidly in a process known as cosmic inflation, causing the universe to grow exponentially in a fraction of a second. As the universe cooled, matter began to form, eventually coalescing into the galaxies, stars, and planets we see today. But even as we gaze back in time and uncover the origins of the universe, we are also looking forward. The future of the universe is just as mysterious and awe-inspiring as its past. One of the most fascinating questions that scientists are currently trying to answer is what will happen to the universe in the distant future. Will it continue expanding forever, or will it eventually collapse in on itself in a cataclysmic event known as the Big Crunch? Or could the universe undergo a transformation in which it begins to contract, leading to a new cycle of creation and destruction? One possibility is that the universe will continue expanding indefinitely. Observations of distant galaxies have shown that they are moving away from us at an accelerating rate, suggesting that the expansion of the universe is speeding up. This discovery, made in the late 1990s, led to the introduction of a mysterious force known as dark energy. Dark energy is believed to be responsible for the acceleration of the universe's expansion, but its true nature remains one of the greatest mysteries in modern physics. Scientists are still unsure about what dark energy is or how it works, but its effects are undeniable. If the expansion of the universe continues at its current rate, the galaxies will eventually move so far apart that the universe will become a cold, dark place, with stars burning out and galaxies drifting into the void. Another possibility is that the universe could eventually stop expanding and begin contracting. This scenario, known as the Big Crunch, would occur if the gravitational pull of all the matter in the universe eventually overcame the force of expansion. In this case, galaxies, stars, and planets would be pulled back together, eventually collapsing into a singularity. This idea was once considered the most likely fate of the universe, but recent observations suggest that the expansion of the universe is actually accelerating, making the Big Crunch less likely. But there is also a third possibility, known as the Big Rip. In this scenario, the expansion of the universe continues to accelerate at an ever-increasing rate until the fabric of space itself is torn apart. This would cause galaxies, stars, planets, and even atoms to be ripped apart, leading to the ultimate destruction of everything in the universe. The Big Rip is still a theoretical concept, but it remains a possibility that scientists are studying as they try to understand the true fate of the cosmos. Regardless of which scenario plays out, the future of the universe is a topic that will continue to fascinate and puzzle scientists for generations to come. What happens to the universe in the far future is one of the greatest unknowns in modern science, and the answers to these questions could change the way we think about space, time, and the very nature of existence itself. But even as we look to the distant future of the universe, we must also turn our gaze inward. The exploration of space has led to countless discoveries about the cosmos, but it has also taught us valuable lessons about our own planet. The Earth is a unique and fragile world, and our actions here will determine the future of humanity and the life that calls this planet home. As we continue to explore the universe, we must remember the importance of preserving our own world, for it is the only home we have ever known. The vastness of the universe and the complexity of the systems within it challenge every preconceived notion we have about space, time, and existence. From the formation of planets to the ultimate fate of stars, each discovery leaves us with more questions than answers, pushing us to rethink our place in this incomprehensibly large universe. These mysterious regions of space, where gravity is so strong that nothing, not even light, can escape, have fascinated scientists and the public alike for decades. Black holes are formed when massive stars exhaust their nuclear fuel and collapse under their own gravity, creating a singularity, a point of infinite density and zero volume. This singularity is surrounded by the event horizon, the boundary beyond which nothing can escape. Once something crosses the event horizon, it is lost to the black hole forever, unable to return or communicate with the outside world. For years, black holes existed only as theoretical objects, their presence inferred from their gravitational effects on nearby stars and gas clouds. It wasn't until 2019 that the first direct image of a black hole was captured by the Event Horizon Telescope, an international collaboration of radio telescopes that combined their observations to create a resolution sharp enough to see the shadow of a black hole. The image, which depicted the supermassive black hole at the center of the galaxy M87, was a groundbreaking moment in astrophysics, confirming what had long been suspected and providing the first direct evidence of these enigmatic objects. Black holes come in various sizes, from stellar mass black holes, which are several times more massive than our Sun, to supermassive black holes, which can have masses billions of times that of the Sun and reside at the centers of most galaxies, including our own Milky Way. The supermassive black hole at the heart of our galaxy, known as Sagittarius A, has a mass of approximately 4 million suns and is a key target for astronomers studying black holes. The behavior of these supermassive black holes plays a crucial role in the formation and evolution of galaxies, influencing the movement of stars and the distribution of matter in the universe. But black holes are not just mysterious, they are also terrifying. The concept of a singularity, a point where the laws of physics as we know them break down, is mind-boggling. In the center of a black hole, matter is crushed to an infinitesimally small point, where the curvature of space-time becomes infinite. Time, as we understand it, ceases to function in any meaningful way. The intense gravitational forces near a black hole also cause extreme tidal forces, stretching and distorting anything that ventures too close, a phenomenon known as spaghettification. It is a fate that no object, not even light, can escape. Yet, despite their destructive nature, black holes are not entirely malevolent. They are also cosmic recyclers, playing a vital role in the evolution of galaxies. Supermassive black holes at the centers of galaxies are thought to be the engines behind the powerful jets of radiation and matter that are ejected from active galactic nuclei. These jets, which can stretch across vast distances, are fueled by the immense gravitational energy of the black hole as it consumes surrounding gas and matter. The process by which black holes create and eject such energy is still not fully understood, but it is clear that they are crucial to the dynamics of galaxies. In addition to their role in galaxy formation, black holes also hold the key to understanding some of the most profound mysteries of the universe. The study of black holes has led to advances in our understanding of space-time, gravity, and even the nature of the universe itself. The famous physicist Stephen Hawking, for example, theorized that black holes could emit radiation, now known as Hawking radiation, which could eventually cause them to evaporate. This groundbreaking idea combined quantum mechanics with general relativity, two pillars of modern physics that are notoriously difficult to reconcile. While Hawking's theory has yet to be experimentally confirmed, it has opened up new avenues of research into the nature of black holes and the fundamental laws of physics. But black holes are not the only extreme objects in the universe. Another fascinating phenomenon is the neutron star, the remnants of massive stars that have exploded in a supernova. Neutron stars are incredibly dense, with masses greater than that of the Sun, but compressed into a sphere only about the size of a city. The density of a neutron star is so extreme that a single cubic centimeter of its material would weigh as much as a mountain on Earth. Despite their small size, neutron stars pack an enormous amount of mass and energy into a tiny volume, creating gravitational fields that can bend light and cause time dilation effects. One of the most extreme types of neutron stars is the magnetar. Magnetars are neutron stars with incredibly strong magnetic fields, up to 1,000 trillion times stronger than Earth's magnetic field. These magnetic fields are so powerful that they can distort space-time and even cause the emission of intense bursts of gamma rays and X-rays. Magnetars are among the most energetic and violent objects in the universe, capable of releasing more energy in a single burst than the Sun does in an entire year. The study of magnetars has provided insights into the behavior of matter and energy under extreme conditions, and they continue to be a subject of intense research. These extreme objects, black holes, neutron stars, and magnetars, are just a few of the many mysteries that the universe holds. As we continue to explore the cosmos, we are constantly reminded of how much we still don't understand. Each discovery raises new questions and challenges our assumptions about the nature of space, time, and matter. The universe is a place of infinite complexity where the boundaries of what we know are constantly being pushed, and our understanding of reality is forever evolving. But even as we peer into the darkest corners of the universe, there is still hope that we may one day find the answers to the greatest questions of all. Will we ever find life on other planets? Will we uncover the secrets of dark matter and dark energy, the mysterious forces that make up most of the universe? Will we ever understand the true nature of black holes and the fundamental laws of the cosmos? These are questions that will continue to drive scientific exploration for generations to come. The future of space exploration holds infinite possibilities. With new telescopes, satellites, and space probes being launched every year, we are constantly pushing the boundaries of what is possible. The James Webb Space Telescope, for example, is poised to revolutionize our understanding of the universe by providing unprecedented views of distant galaxies, stars, and exoplanets. It will allow us to look back in time to the early stages of the universe and possibly even detect the first signs of life on planets beyond our own solar system. As we look to the future, it's impossible not to be filled with a sense of wonder and excitement. The universe is vast, mysterious, and full of potential. The discoveries we've made so far are just the beginning, and who knows what new frontiers we will explore in the years to come. But one thing is certain, the universe will continue to captivate our imaginations and challenge our understanding, pushing us to reach for the stars and beyond. As we approach the final stages of our journey through the cosmos, it's only fitting that we reflect on the enormity and significance of what we've discovered. From the birth of stars to the mysteries of black holes, our exploration of the universe has taken us on a ride through space and time, showing us not just the wonders but also the dark, inhospitable corners that challenge everything we thought we knew about reality. One of the most captivating aspects of our universe is the relentless and mysterious forces that shape it. Forces like dark energy and dark matter. These unseen components make up nearly 95% of the universe, yet we know almost nothing about them. They don't emit light or radiation, making them nearly impossible to detect directly. Yet their influence is undeniable. Dark energy, for example, is responsible for the accelerated expansion of the universe. It's a force that seems to push galaxies farther apart, causing the very fabric of space itself to stretch at an ever-increasing rate. Scientists have been able to observe its effects, but its true nature remains one of the greatest mysteries in modern astrophysics. Dark matter, on the other hand, is thought to be the invisible substance that makes up most of the mass in the universe. Though we can't see it directly, we can observe its gravitational effects on galaxies and galaxy clusters. Without dark matter, galaxies would fly apart as they don't have enough visible mass to hold together. This invisible matter forms a sort of cosmic scaffolding, providing the gravitational pull needed to keep galaxies intact. But like dark energy, dark matter remains elusive. We've been searching for it for decades, but so far, it has managed to evade detection, leaving astronomers with only clues and theories to work with. These two forces, dark energy and dark matter, are fundamental to understanding the evolution and structure of the universe. Without them, the cosmos as we know it would be a very different place. And yet, for all our technological advances and discoveries, we are still far from understanding them. They represent the unknown frontier of space exploration, an area where the laws of physics as we understand them break down, and new rules may emerge. As we gaze further into the depths of space, we are reminded of how much we still have to learn. Even with all the telescopes, space probes, and satellite missions, we've only scratched the surface of what the universe has to offer. There are still countless exoplanets to be discovered, many of which could hold the key to understanding life beyond Earth. The search for life on other planets has been one of humanity's greatest endeavors, and with every new exoplanet we find, the possibility of discovering a second Earth becomes more and more tantalizing. We've also seen how the universe itself is constantly evolving, the birth and death of stars, the collision of galaxies, and the eventual fate of planets and black holes all contribute to the ongoing story of the cosmos. And yet, despite the many forces at play, the universe is vast and seemingly indifferent to the existence of life. It continues to unfold in ways we can only begin to comprehend, leaving us in awe of its complexity and beauty. Perhaps one of the most humbling aspects of our exploration is the realization of how small and fragile our own planet is in the grand scheme of things. Earth, with all its wonders, is but a tiny speck in the vast expanse of space. Yet, despite our minuscule place in the cosmos, we have the capacity for curiosity, for wonder, and for discovery. We are driven by a desire to understand the universe, not just to survive, but to thrive in it. We seek knowledge not just for ourselves, but for the generations to come, in hopes that one day humanity will have the answers to the questions that have long eluded us. As we conclude this journey through the universe, it's important to recognize how far we've come and how far we still have to go. The future of space exploration holds endless possibilities. With new technologies on the horizon, such as the James Webb Space Telescope and future space probes, the potential for discovery is limitless. Who knows what we'll find next? Perhaps we'll uncover the secrets of dark energy and dark matter, or maybe we'll discover a habitable exoplanet orbiting a distant star. The journey of exploration is far from over, and the universe continues to beckon us forward. But for now, we leave you with this thought. The universe is vast, and we are but a small part of it. Yet in our quest for knowledge, we continue to uncover the unimaginable. And with each discovery, we come one step closer to understanding the mysteries of the cosmos. Thank you for joining us on this incredible journey through space. As we look to the stars, we can only wonder, what's next? The universe is waiting, and the story is far from over.